Good morning to all. Today our topic is dispersion of white light through prism. So you know well what do you mean by dispersion? Dispersion is nothing but it's a splitting of light, which means dispersion is a splitting of white light into constituent colors, like GR. I mean violet to red. This is called as dispersion. It's simply called as polychromatic light. It means that the light is just simply classified two types: monochromatic. Monochromatic light means it has only one frequency, one wavelength. Polychromatic means it is a many wavelength and frequency also. So, for a good example, sunlight and a mercury lamp. This is a good example of polychromatic light. And now we are discussing about dispersion. When the white light is incident on the prism, just fall on the prism. I mean the white light is just split colors. Region violet to red. Region violet to red. See, the dispersion is splitting of white light into its constitute colors of violet to red is called as dispersion, which means if consider prism, this is angle of prism, know well. Angle of prism, when white light incidents on the surface, when the white light incidents on the surface of prism, this is white light. This light is splitting of colors, violet to red, which means listen to me. This is colors just splitter, violet. I mean with GR, violet to red. And after, just consider this is a medium, air medium. For example, prism is a glass, that's why it's a denser medium. This is air medium. You know well, rarer to denser after refraction bend towards normal. Just I want to take this is a normal line. This is a normal to the surface. When this is an incidence, angle of incidence. This is angle of incidence I. If white light incidence on the surface, this is a white light incidence on the surface of prism. These white light is splitting to violet to red. I mean the colors, the region of just memorize this short name. GYOR, violet to red, violet, indigo, blue, green, yellow, orange, and red. So violet light incidence on the surface of prism. These light is splitted colors like violet to red. What is the reason? I explain this. First of all, why deviation? Which one is the deviator the most, and which one is the least? First one is the medium, air to denser. You know when the light incidence rarer from denser, what happened after refraction? Bend towards normal. Just instance, I want to take this is simple one light. This is monochromatic light, angle of incidence, normal after refraction. This is a straight light, instant light. But is deviator bend towards normal. This is angle of refraction. This range. I mean, this is also refraction. For example, violet to red. So this is angle of refraction. This is angle of refraction for red. This is angle of refraction for violet. So the angle of refraction is maximum for red. Maximum for red light. I mean red color. So the light incidence from rarer to denser. What happened? The refraction is available. The refracted rays bend towards normal. Refracted rays bend towards normal because of the medium of denser. I mean the medium of prism is denser. And after this is, for example, this is an incident ray. I want to take this, our convenient. So now color travel from glass to further and air medium. So denser to rarer. What happened? Denser to rarer after refraction bend away from normal. Yes, I want to take violet, normal, is away from normal. Away from normal. This is the emergent ray, you know well. This is emergent ray. This is a violet, and next one is this is red. Violet to red. So bend away from normal. So this is a violet light. The polychromatic light is incident on the surface of prism is a splitting of colors like violet to red. Dispersion. This is phenomena is called as dispersion. Dispersion means splitting of white light. Splitting of white light into constant colors like violet to red. This is phenomena. This phenomena is called as dispersion. The medium is called dispersive medium. Dispersive medium. So just I want to take this, which one color as maximum deviated. I want to calculate the deviation angle. Deviation. What do you mean by deviation? So the angle between the incident ray and the emergent ray is called as angle of deviation. Angle of deviation. So this is emergent ray. I want to take this. This is angle of deviation. So which color has the maximum deviation? Maximum deviation is violet. Violet has a maximum deviation. So I want to take the deviation angle. Just simple del is equal to del B. B means a violet color. This is del R. R means red color. So maximum deviation is the record as a violet color. What is the reason? First of all, why the dispersion is required? Is a very important. The velocity of colors, all colors should travel in same velocity in medium. All colors should travel same velocity in medium of air. In medium of air. So just I want to take the medium air or vacuum. All colors, the violet to red colors should travel in same velocity. Same velocity. But the entire medium, any one of the medium, any one of the medium, enter these colors, the velocity of color should be changed. Velocity of color should be changed. So that's why the dispersion is recorded in prism. It is a main reason. And next one is also, and next reason also. According to Snell's law, mu is equal to sin I by sin. Mu is equal to sin I divided by sin R. Who is sin I? Who is I? Angle of incidence. Who is R? Angle of refraction. So according to Snell's law, second medium with respect to first medium, which is equal to mu is equal to sin I divided by sin R. The angle of incidence is all colors is same. All colors. The angle of incidence of all colors is same. But the angle of refraction should be varied. Angle of refraction should be varied. If angle of refraction is maximum for red color, for example, this is a deviator, this violet, this is red. So the angle of refraction is maximum refraction. Angle of refraction is greater than violet. The refraction for red color. This is violet. Refraction is red as a maximum refraction. So refraction maximum means refractive index of in medium. I want to calculate the refractive index of red color. I want to red color or refractive index of red color. Refractive index maximum. So this is angle of refraction is maximum. So refractive index is minimum for red color. Refractive index is minimum for red color. Mu red and mu violet. Mu violet. Mu red and mu violet. So which one has a minimum refractive index? Angle of refraction in a medium of prism is maximum refraction. So red color has maximum refraction, violet has a minimum refraction. Angle of incidence is same for all colors. So This is angle of refraction is maximum for red color. So refractive index is minimum for red color. This is a relation between according to Snell's law, mu is equal to sin I divided by sin R. So which color has a maximum refractive index? The refractive index is violet is a maximum. It is a very, very, very important. First case, the refractive index of violet has a maximum. Refractive index of violet has maximum. According to Snell's law, mu is equal to sin I by sin R from one medium to another medium, rarer to denser medium. Sin I divided by sin R. Sin I is nothing but sin of angle of incidence. I is nothing but angle of incidence. R is nothing but angle of refraction. So which one has a maximum refraction? Red color has a maximum refraction. So angle of incidence is same for all colors. There is no any problem. So this is a constant. What is the relation between refractive index and refraction? So angle of refraction is a maximum red. So refractive index is minimum for red color. This is a inversely proportional. That's why listen to me. The violet light incidence on the prism. The refractive index of color should be there. Refractive index of color should be there. And next one is C is equal to mu lambda. What is it? C is the velocity of light. Nu is the frequency of light. Lambda is the wavelength of light. You know well which one is a constant from one medium. Light travel from one medium to another medium. The frequency of light is not changed. So it remains constant. So the velocity changes or wavelength changes. Wavelength changes, velocity corresponding velocity changes. So velocity changes, corresponding wavelength changes. So frequency remains constant. So that's why this is the main reason. And next one is, listen to me. So it's the main reason one for denser to rarer, the color is not changed. Denser to rarer, the color is not changed. This is also violet, this is a red. The frequency remains constant. That's why the color is not changed. The color of light in traveling medium depends upon the frequency. That's why it's the main reason for one more questions. So why the medium color of light travel from denser to rarer is not the color change because of it depends upon the frequency. The frequency is not changed from denser to rarer. Not changed from denser to rarer. I mean the one medium to another medium frequency is not changed, but the wavelength should be changed. And next one is, what is the refractive index of violet? According to Snell's law, refraction is variable, angle of refraction variable. That's why refractive index is also variable. So the refractive index of violet color is greater than refractive index of red color. Am I right? Correct. And next one, the colors splitter emergent from denser to rarer medium, violet to red, with GR. These bands of colors of light called spectrum. Bands of colors called as spectrum. Listen to me. Bands of colors is called as spectrum. I mean, bands of colors of light is called as spectrum. Our first result is refractive index of violet is maximum compared to refractive index of red color. This is the main reason. That's why the violet color is incidence on the surface of the prism. The color should be dispersed, right? The splitting of violet. This is the main reason. And another one reason is velocity. Velocity of colors is also changed. It is a very important concept also. The velocity of light or velocity of colors is constant in medium of air or vacuum, which means there is no change. I mean, 3 should travel in light velocity, 3 into 10 power 8 meter per second, as usual light velocity. All colors like here, violet to red color, all colors should travel in same velocity in medium of air and vacuum. But enter any medium, the velocity of colors should be changes. The velocity of colors should be changes. It is a very, very, very important. Why velocity changes? Because of refractive index changes. Why refractive index changes? Because of angle of refraction changes. Angle of refraction changes. Corresponding angle of incidence also. Because of angle of incidence is constant for all colors. It's not changed. That is the main reason for dispersion when white light phenomena of dispersion when white light incidence on the surface of prism. That's why the color should be dispersed. And next one is refractive index, and next one is the velocity. Velocity of colors is a very important. Violet to red, the velocity of all colors travel in same velocity, like light velocity 3 into 10 power 8 meters per second, no changes. When the violet color and red color velocity changes. So which one is a maximum, which one is the minimum? The violet ray travels with the smaller velocity, violet, because of the deviation is minimum. What is the deviation? Angle of deviation. I want to get this. Listen to me. The violet light incidence. This is violet. Air medium. This is denser medium. Further air medium. Rarer to denser, denser to rarer. I have to calculate this is. I want to draw the line. Angle of refraction. This is a violet light. This is white light. This is violet light. I want to take this emergent violet light. And after, this is red color. Red. This is violet. So the refraction angle of red is the maximum, we know well, and the minimum. And the angle of deviation, So which one has a maximum angle of deviation? The angle of deviation is maximum for violet color. Deviation angle. Violet is greater than deviation of red. Angle of deviation is maximum. Angle of deviation is maximum for violet color compared to red color. That's why I mean the violet light incidence in a prism, incident on the surface of prism, is according to basis of dispersion. The color should be deviated basis on refraction angle, refractive index, and wavelength also. And deviation angle is violet. I mean deviation angle of violet del V is a maximum. Why? Because of velocity also vary. So the colors in air medium or vacuum is a 3 into 10 power 8 meter per second. Light velocity is not change. All colors travel in same velocity. It's no problem. But entering a medium, the velocity is also changed. So which color has a maximum velocity? In a medium, red color has a maximum velocity. Velocity, V for velocity, is greater than velocity of violet. Velocity is maximum. The violet ray travel with a smaller velocity in a medium. Violet is travel in smaller velocity in medium, but in medium, red has a maximum velocity. Maximum velocity. It is a very important. So that's why the deviation of angle is maximum for violet. I mean, red light should travel high fast. I mean, the velocity is the maximum for red. So velocity is minimum for in medium of prism. That's why the deviation angle is maximum. That's why the deviation angle is maximum. Why deviation angle of violet is maximum? In velocity of violet color in medium is less value compared than red color. Red color has a maximum velocity. That's why just fast to travel. I mean, travel from denser to rarer, rarer to denser. Velocity maximum. That's why the deviation is a minimum. So the deviation is maximum for violet color because of the velocity is minimum. Velocity is minimum compared than red. So this is another one main concept. Velocity is maximum in medium. Which color? Red. Minimum is violet. And deviation angle is maximum for violet. Minimum for red. These are two concepts is compare. I mean compare then violet and velocity and deviation. Depends on. I mean this is depends on velocity. That's why there's a maximum deviation, minimum deviation. And next one is each color of light. Each color of light associated with a definite wavelength. Definite wavelength. You know well which color has a maximum wavelength. Red has a maximum wavelength. You know well. Red color wavelength. Red. Wavelength of red is maximum. Wavelength of red is maximum, and compare then wavelength of violet. So wavelength is maximum for red. Wavelength is maximum for red. That's why you know well the danger symbol and the police station, fire service radars. Most of them, this is a red color because of the wavelength is maximum. Minimum wavelength reaches maximum distance. That's why the wavelength of red is maximum compared to the wavelength of violet. So wavelength is maximum for red color. Wavelength is maximum for red color. So relation between wavelength and the frequency, C is equal to nu lambda, and nu is equal to C divided by lambda. C is the velocity of light, is constant in medium of air and vacuum. The relation between frequency and wavelength is inversely proportional. Inversely proportional. So violet to red. Violet to red. Wavelength maximum for red. Wavelength minimum for violet. So frequency is inversely proportional to wavelength. I mean inversely proportional means wavelength maximum means frequency minimum. Wavelength maximum means frequency minimum. See, I want to calculate the frequency of violet and frequency of red. Wavelength maximum inversely proportional. So upper frequency minimum. And the wavelength is minimum, so frequency is maximum. Frequency is maximum. There's another one main for colors. So violet to red and red to violet. Wavelength is maximum for red color. Wavelength is minimum for violet. Wavelength and frequency is inversely proportional. Number of waves per second, number of waves produced per second is called as frequency. Number of waves produced per second is called as frequency. You know well, reciprocal of frequency is equal to time t. You know well. So wavelength is maximum means frequency minimum. Wavelength maximum means frequency minimum. Wavelength minimum means frequency maximum. Frequency maximum. This is a main concept of dispersion of light. So what do you mean by dispersion? Dispersion is splitting of white light into constitute of colors like violet to red is called as dispersion. I mean the bands of colors of light is called as spectrum. First one is violet is most deviated and the red the least deviated. Which one has the most deviation? Red, I mean the violet has the most deviation. Del is the symbol of deviation and red is the minimum. Violet is the most deviation, red is minimum deviation. Del means symbol of deviation. And refractive index of color. Which color has the maximum refractive index? Listen to me. This is a keyword for examination. And points also. Just take notes. And del V greater than del R. Del means deviation, angle of deviation. So which color has an angle of deviation is maximum? Violet. Compare than red. And next one is refractive index. So refractive index means mu or n. Refractive index of medium, mu or n. Any one of these. Just I want to take this mu. Refractive index of color of refractive index in the medium of prism. Which one is deviation? I mean refractive is violet has a maximum refraction greater than refractive index of red. And next one is velocity. Which color has a maximum velocity? Red. Velocity means v. V means velocity. Red has a maximum velocity. Compare than violet. Maximum velocity in medium of prism. Red color has a maximum velocity. The velocity maximum. That's why deviation is minimum. And next one is wavelength. Which color has a maximum wavelength? Fourth point is maximum wavelength. Lambda. Symbol of wavelength is lambda. Which color has a maximum wavelength? Red has a maximum wavelength. Red is maximum wavelength and violet is a minimum wavelength. And next one is frequency. Frequency is means so frequency, the relation between frequency and wavelength, inversely proportional. So frequency F, which has a maximum frequency, violet has a maximum frequency. Because of wavelength minimum, so frequency maximum. Violet and red. Frequency is minimum for red, maximum for white. In these 3, 4, 1, 2, 3, 4, 5 concept is basis of dispersion. This is a 5 concept is the basis of dispersion. This is a dispersion, record dispersion on prism. I mean the violet is the splitting of white rays. First one is a main important deviation angle for violet is maximum compared than red. What is the reason? The velocity of red color is maximum in medium. Velocity of red color is maximum in red color. Velocity of red color maximum in medium of prism. That's why the deviation value is minimum. Refractive index of violet is greater than refractive index of red because of, according to Snell's law, angle of mu is equal to sin I by sin R. Sin I is a constant for all colors, it's not changed. Refraction, angle of refraction in medium of prism should be varied. So red has a maximum refraction, so inversely proportional to refractive index. That's why refractive index is minimum for red color. So refractive index of violet is maximum compared than red color. And next one is velocity. Velocity is, the red color velocity is maximum compared than violet. And as usual, you know well, wavelength of red color is maximum for red, minimum for violet, and the reciprocal of wavelength. Inversely proportional to wavelength, which means C is equal to nu lambda. Nu is equal to C by lambda. C is the velocity of light. For just I want to take medium of air medium. So frequency is inversely proportional to wavelength. So wavelength maximum means the frequency minimum. Frequency minimum means wavelength maximum. See, red has a maximum wavelength, so frequency minimum. Violet has a minimum wavelength, so frequency maximum. Frequency is nothing but number of waves produced per second is called as frequency. Our textbook concept, violet is the most deviation. Okay, violet is most deviation. And next one is the color obtained in the spectrum depend on nature of the source of the light. It is a very, very, very important keyword. Another one keyword. See, color obtained in a spectrum. Color obtained in a spectrum depends on nature of the source of the light. Nature of the source of the light. Nature of the source of light. Already I informed you monochromatic light and polychromatic light. So that's why the colors is a difference upon. If monochromatic light means the single color only dispersed, and there is no any dispersion, only single color. Polychromatic means record dispersion. So the white light is a splitting in colors. So that's why the nature of nature of source of light. Who is this? The color obtained. The color obtained is depends on nature of the source of light, and each color of light is associated with a definite wavelength. You know well, each and every color in prism, each and every color. This is violet to red. Each and every color definite wavelength. Violet has a minimum wavelength, red has maximum wavelength. Frequency minimum for red, maximum for violet. And you know well, red is the longest wavelength compared than violet. Violet ray travel with smaller velocity. Violet ray travel with small velocity. That's why deviation is minimum. So compare than red color. The refractive index of material of prism is different for different colors. Well, refractive index of prism in colors is different for different colors. So which one is the maximum refractive index of color? Refractive index violet maximum, minimum red. Violet refractive index maximum and red refractive index minimum. In vacuum, all colors should travel with the same velocity. Vacuum, all colors should travel with the same velocity. Okay, these 5 points are very important. The 5 points are included in this dispersion of white light. The remaining is no problem. And next one is speed of light is independent of wavelength in vacuum. This is a very important point. Speed of light is very important. See, in the examination point of view, speed of light is independent of wavelength, where it is a very important medium of vacuum. In medium of vacuum, the speed of light is independent of wavelength in medium of vacuum, but entirely in medium dependent. So therefore, vacuum is non-dispersive medium, and also the all colors travel with the same speed in the medium of air and vacuum. But entirely in medium, any one of the medium should be changed. The velocity of color should be changed. So which color has a maximum velocity? Red has a maximum velocity. Compare then violet. In entering medium, the velocity should be changed. This is the main concept. I mean the dispersion of white light. The 5 point is a very first 5 point. The deviation angle is a maximum for violet, and refractive index maximum for violet compared with red. Velocity of red is maximum for violet in a medium, but in a medium of air means it's constant. Medium of air or vacuum, all colors should travel in the same velocity, but enter in medium, the velocity of colors should be changed, and wavelength is also changed, and frequency is also changed, and refractive index of colors is also changed, and the deviation is also variable. These 5 points are very important. And next one is dispersion angle. Angular dispersion. I want to calculate this angular dispersion. In our textbook, angular dispersion is nothing but the deviation, angle of deviation, suppression by extreme colors. I mean the difference between violet to red. Deviation angle del V minus del R. This is angular deviation. Angular dispersion. The suppression between the two extreme colors in a spectrum is called as the angular dispersion. See, the angular dispersion is a very important concept also because of, see, angular dispersion. See, when light incidents on the prism, this is violet, this is red. This is the angle of deviation. This is the deviation angle of red. This is deviation angle of del V. Which one has a maximum angle deviation? Violet is a maximum and red is minimum. This is, you know well. I want to calculate the angular dispersion. Angular dispersion means in term del V minus del R is the angular dispersion. Difference between deviation angle and extreme colors. Extreme colors means violet to red. Extreme colors means violet to red. Del V, angle of deviation for violet color. Del R, angle of deviation for red color. The difference, separation between. The difference between violet and red. Extreme colors. Any extreme colors. Just I want to take any colors of picture. Most of them, this angle of dispersion is measured from picture means VI, B, G, Y, O, or picture. First two colors not considered because of it's a very sensitive for our human eye. I can't identify this. Most of them just record blue to red. Blue to red. The angular dispersion we are always measure blue to red. Most of them, because of violet and indigo is very sensible for the human eye. It's gone to identify this. Most of them. That's why. And del V minus del R. Del V minus del R. Del V minus del R means the difference between angle of deviation for extreme two colors. This is called as angular dispersion. The term del V minus del R is the angular separation between the two extreme colors in the spectrum is called angular dispersion. Angular dispersion. It is mainly depends on angle of prism. Angular dispersion is a depends on angle of prism and nature of the material of the medium. I want to prove this. You know well, refractive index of prism. The formula should be calculated. The refractive index of prism n is equal to sin of a plus d divided by 2 whole divided by sin a by 2. Sin a by 2. This is a deviation angle. A is angle of prism. A is nothing but this is angle of prism, and D is a deviation angle. Deviation angle. Just I want to take two colors, extreme colors, violet and red. So the refractive index of medium n is equal to sin a plus, D goes to del, deviation angle. So divide by 2 whole divided by sin a by 2. For a small angle of prism, means a value is almost is a very very small and reach it 10 degree. Small angle of prism. So the value of sin of a plus del divided by 2 is equal to, sin theta is equal to theta. So sin of a plus del divided by 2, which is equal to a plus del divided by 2. For small angle of prism. Small angle of prism. Small angle of prism. 10 degree means, reach it at 10 degree means sin theta is equal to theta. Just I want to take the two color, extreme two colors. Angle of deviation of violet is del V is equal to deviation angle of violet color. Deviation angle of violet, and del R means deviation angle of red. Deviation angle of red. And mu R N R. Mu R N. This is refractive index. Refractive index of red color, and mu V or NV. Who is this? Mu R and NV. Mu and N both are equal. In our textbook, most of the regions are using N, but mu is a symbol of refractive also. So this is a refractive index. And next one is del V and del R is deviation angle of violet and deviation angle of red color. And also sin of mu is equal to sin a plus del divided by 2 whole divided by sin a by 2. A very small angle, sin theta is equal to theta. That's why the formula is simplified as refractive index n is equal to sin of a plus del, which means a plus del divided by 2 whole divided by a by 2, which means sin theta is equal to theta. Sin theta is equal to theta. Just simplify this. I want to calculate the refractive index of the medium. N is equal to a plus del divided by 2 into 2 divided by a. So 2 cancel. So n is equal to a plus del whole divided by a, which is equal to 1 plus del divided by a. 1 plus del divided by a. So n is equal to refractive index of medium is equal to 1 plus del by a. So the positive one is goes to other side, n minus 1 equal to del by a. So I want to calculate the deviation is equal to n minus 1 into a. This is a deviation angle. I mean deviation is equal to n minus 1 into a. This deviation is mainly depends on a angle of prism. Deviation is mainly depends on refractive index. Refractive index, which means the refractive index, I mean the deviation is angular deviation is equal to, it depends on angle of prism and the nature of the material of the prism. This is a angular deviation formula, which is equal to del is equal to n minus 1 into a. This is the main concept. Del is equal to n minus 1 into a. Mainly depends on angular dispersion, is mainly depends on angle of prism and the refractive index of the medium. Refractive index of the medium. Thus, I want to take this two extreme colors. This is a deviation angle. But I want to calculate this del B value and the del R value. Whose is dispersion, angular dispersion, separation between extreme colors, del B minus del R. Del B minus del R. This is a dispersion, angular dispersion. But I want a general formula, del is equal to, deviation is equal to n minus 1 into a. N is the refractive index, a is the angle of prism. So I want to substitute this equation for violet color and red color. See, what is this? Violet, del B is equal to, deviation of violet is equal to refractive index of violet minus 1 into a. So equation number 1. Am I right? General formula, but this is used in violet color. And del R, deviation of red color, which is equal to refractive index of red minus 1 into a. This is equation number 2. I want to get the difference. Subtract del V minus del R is equal to, what is this? NV minus 1 into A minus of NR minus 1 into A. Just cancel the value. Del B minus del R is equal to refractive index of violet into A minus A. I mean, this is minus refractive index of red into A. I mean, this is negative. This is also negative. Negative into negative is positive. So positive 1 into A. So for negative value, positive value cancel. What is the remaining value? Del V minus del R is equal to refractive index of violet NVA minus NRA. The common factor is A. So del V minus del R is equal to NV minus NR into A. This is equation of angular dispersion. This is the equation of angular dispersion. What is this angular dispersion? The angular dispersion is, what is this? The extreme color. I mean the angular dispersion between the two extreme color in the spectrum is called as angular dispersion. So del V minus del R is nothing but this is the angular dispersion. Angular dispersion del V minus del R is equal to NV minus NR into A. NV minus NR into A. It is a very, very, very important. I mean, N is a refractive index of violet. NV is a refractive index of violet. NR is a refractive index of red color. Del V is a deviation of violet. Del R is the deviation of red. The difference between del V minus del R is the extreme separation between extreme two colors. This is nothing but this is dispersion. This is angular dispersion. Del V minus del R is equal to NV minus NR into A. This is angular dispersion. And our next important topic, another one topic is dispersive power. Dispersive power. First one is the dispersion, second one is the angular dispersion, third one is dispersive power. So dispersive power, the symbol of dispersive power is equal to omega. What is the dispersive power? The dispersive power is nothing but this is ratio between angular dispersion del V minus del R and in mean deviation of ray. I mean mean ray means mean color means for almost green or yellow. GYOR, which your VIBGYOR. Listen to me. VIBGYOR. Almost green and yellow is a mean ray. I mean mean color. VIBGYOR. The mean color was is a mean color, green or yellow. Most of them. What is this dispersive power? Dispersive power is nothing but this is a ratio of angular dispersion to the mean angle of deviation for mean color. Angle of deviation for mean color. Mean color. What is a mean color? I want to take red color. That's why. Sorry, yellow color. So del y. Del y means yellow. Del y. Del V minus del R is nothing but this angular dispersion. Del Y is nothing but this a mean color of, I mean deviation of mean color. What is a mean color? Almost yellow. Almost yellow. Because of first two colors is most of them is not visible, sensitive, not sensitive for human eye. That's why most of them we are recording yellow color, mean color. Which one is a mean color? Yellow one is a record. Because of first violet and indigo is very sensible for human eyes, can't to identify the two colors. That's why in VIBGYOR, violet and indigo can't to identify. The identification is very difficult. That's why most of them blue to red in mean color, which is a mean color, yellow is a mean value. So dispersive power is nothing but the ratio between angular dispersion to the angular deviation of mean. Angular deviation of mean. It is a very, very, very important one. I want to calculate this. Dispersive power omega is equal to. Substitute the value. What is del V minus del R value? Yes. W is equal to del V minus del R. Del V minus del R is the angular dispersion. Substitute the value NV minus NR into A divided by NV minus NR into A divided by deviation. Angle of deviation formula is del is equal to, what is the del formula? N minus 1 into A. Where this? This is del is equal to n minus 1 into A. This is n minus 1 into A. Whose is n? Refractive index. So I want to use the yellow color. So del is equal to n minus 1 into A. So just I want to take the mean ray is this yellow, the refractive index of n yellow. Sorry, wavelength symbol. Del yellow y is equal to n minus 1 into A. N minus 1 into A. Just substitute the value. Yellow means del y. Yellow color, just indicate yellow color. N minus 1 into A So yellow, that's why we are indicate white. Ny minus 1. This is a dispersive power. What do you mean by dispersive power? The ratio of angular dispersion to the angle of deviation for mean color. Mean color. Just simplify this. Dispersive power is equal to dispersive power. So omega is equal to NV minus NR into, I mean, AA cancel. AA cancel. Divided by NY minus 1. NY minus 1. This is a formula of dispersive power. Formula of dispersive power. It is a very, very, very important. Our first topic is dispersion. Our second topic is angular dispersion. Our third topic is dispersive power. Dispersive power. And it's a very important notes. Just take this first point. Dispersive power is a dimensionless quantity. Dimensionless quantity. First, dispersive power as dimensionless quantity. There is no unit because of this is also refractive index. This is also refractive index. So there is no change. I mean there is no value because of ratio value. So no unit. No unit. And next one is a very important one. This is always positive. Always positive. This value and this value is also positive. That's why always positive. And last one is dispersive power is depends nature of material. This is also refractive index of violet. This is also refractive index of red. This is also refractive index of yellow. Depends upon the refractive index is the refractive index of colors should identify in a medium. So it is a very important. Depends on nature of the material of the prism. Omega is a depends upon the nature of the material of the prism. I mean because of omega is equal to NV minus NR divided by NY minus 1. NY minus 1. Ny minus 1. This is the equation of dispersive power. Omega is equal to NV minus NR divided by NY minus 1. These are three concepts of very, very important. First concept is dispersion, and second order concept is angular dispersion. And third one is dispersive power. These are the main three concepts of dispersion of violet through prism. Dispersion of violet through prism. Okay. Okay, friends, just recall this. I give you some examples. I want an answer from you. What do you mean by dispersion? Hello? Okay, there are some questions I want to answer. What do you mean by dispersion?
Splitting of white light into its constituent colors.
Very good. Just splitting of violet in a medium, particularly is very important in a medium, particularly polychromatic. Okay. Which color has a maximum deviation?
Violet.
Minimum deviation?
Red color.
Very good. So velocity of which color has a maximum velocity?
Red color. Red color.
Very good. What is the velocity of yellow color in vacuum?
3 into 10 power 8. It is same for all colors in vacuum.
Very good. All colors will travel in same velocity in medium of air and vacuum. Okay.
Yes,
So which
sir.
is maximum velocity in medium?
Red color.
Very good. Red. Minimum wavelength.
Red color.
Violet color.
Violet color.
Minimum wavelength.
Violet color.
Maximum frequency.
Violet color.
Violet color.
Maximum wavelength.
Red color.
Minimum frequency.
Red color.
Red color.
Angle of refraction is minimum for
Violet color.
very good. Violet. Refraction
Violet.
is maximum for angle of refraction is maximum.
Red
Violet
color.
color.
No. Angle of refraction.
Red
Violet.
color.
Red.
See, del V is the deviation. Just identify this. Del V is a deviation. I want to calculate the refraction. According to Snell's law, mu is equal to sin I divided by sin R. The angle of incidence is when dispersion, the angle of incidence is same for all colors. Am I right?
For all color.
Very
Yes,
good.
sir.
This is the incident light. Am I right? Splitting violet to red. I mean, the angle of incidence is same for all colors. Okay. But refraction is varied. Which one is the maximum refraction?
Red color.
Minimum refraction?
Violet.
Violet.
Very good. That's why the refractive index should be violet as a maximum, red as minimum.
Minimum.
Very good. And next question is, what do you mean by angular dispersion?
It is the angular separation between two extreme colors.
Very good. Two extreme colors, particularly violet to red. Most of them angular separation is calculated by blue to red also. Okay. Blue to
Red.
violet and indigo is a very sensible. You can't to identify. It's a difficult one. That's why most of them measured red, blue to red. And what is the deviation formula? Del is equal to
Del equal to n minus 1 into A.
n minus 1 into A. Del V is the violet color and del R is the red color. Del V minus del R is nothing but this is a angular dispersion. Am I right?
Yes,
So
sir.
del V minus del R del V minus del R divided by del Y. Who's this?
Dispersion power.
Dispersion power.
Dispersive power. Very good. I give you on some problem. Anyone say answer? Very easy one. So del V is equal to 3.25 degree and del R is equal to 3.15 degree. What is angular dispersion? What's the formula?
Del V minus del R equal to NV minus NR into A.
Del V minus del R is equal to NV minus NR into A. Am I right? But you have del V minus del R value. What is the answer? 3.25 minus 3.10, which is equal to 3.25, 3.15. What is this? 3.15, 0.10 degree. 0.10 degree. And next one is NV will be equal to NV is equal to 1.685. 1.685. NR is equal to 1.644 and A is equal to 4 degree. What is the angular dispersion? I give you formula. What is formula? NV minus NR into A. Anyone? Very easy one. Hello, students. Hello.
0.164.
Very good. 0.164. And next one. Very good. Del V is equal to 3.72 degree. And del Y is equal to 3.28 degree. And del R is equal to 2.84 degree. What is dispersive power? I give you formula. Dispersive power which is equal to, what's the formula?
Del V minus del R by del Y.
Very good. The answer. Omega is equal to del V minus del R divided by del Y. What is the value del V? 3.72 minus 2.84.
Dispersive power equal to 0.27 degrees.
Very good. 2 omega is equal to 0.268. Correct answer. So omega is equal to
268.
Very good. Del Y is equal to 3.28. Omega is equal to 3.72 minus 2.84 divided by 3.28. The final answer is equal to 0.268 or 0.27.
285.
Very good. Thank you. Thank you, students. We will meet next class. Thank you to all. Bye.